Hi there, welcome to Mr. Lehan Teaches You Stuff. This is grade 10 Optics Lesson 5, Reflections. So one of the important bits about reflections is that when light strikes a mirror, it bounces off at the same angle it came in at, just like a ball on a pool table. So if you're playing pool and you strike the ball and it hits the side, it bounces off at the same angle relative to the edge of the pool table that it came in at. The same thing happens with light. When it strikes a mirror, it's going to bounce off at the same angle relative to the mirror. Now when we're doing drawings of light reflecting off mirrors, we've got a few terms that we need to remember. The normal is the imaginary line perpendicular to the surface of the mirror at the point of reflection. So this right here is the normal, that little purple line there. So that's always just going to be perpendicular to the surface of the mirror. The incoming ray of light is called the incident ray. So that's the green ray there. And the angle between the normal and the incident ray is called the angle of incidence. So that's the angle of incidence. The rays that have reflected off the mirror are called reflected rays. So that's a reflected ray there. And the angle between the normal and the reflected ray is the angle of reflection. So that's the angle of reflection. And this is important to understand the law of reflection. So when light reflects off a surface, the angle of incidence always equals the angle of reflection. So theta I always equals theta R. So if we have light bounce off this mirror, our normal goes up through the center, perpendicular to the mirror, and theta I, or the incident, or the angle of incidence, is going to equal theta R, which is the angle of reflection. So those two angles will always be equal. Alright, now let's take a look at this duck who's taking a look at itself in the mirror. The duck is looking in a plane mirror, and this is a mirror that has a flat reflective surface, so it's not curved. So the majority of mirrors that you run into in your day-to-day life will be plane mirrors. So how do these plane mirrors work? Well, when the duck looks at the mirror, light rays are coming in, they're hitting the duck, they're bouncing off the duck, and then hitting the mirror. So let's say light rays from the top and the bottom of the duck's head bounce off the mirror and go into the duck's eyes. What that duck is seeing is, if we extend the light rays that are coming into the duck's eyes out behind the mirror, he's seeing a virtual duck behind the mirror. And this is a virtual image. Plane mirrors create virtual images. And it's a virtual image because it can't be projected on a screen. So if you go behind that mirror and you hold up a piece of paper, it will not have a duck be projected on that screen, which sounds kind of obvious. But when we look at other types of mirrors, they can actually create real images that can be projected onto screens. And we'll see that later. Concave mirrors. There's two types of curved mirrors. One type's a concave mirror. Concave mirrors curve inward like a bowl or like a cave. And the light rays are always reflected into a focal point. So if we draw a normal line here, we've got a focal point right there, that little green dot. So when light rays come in and hit this mirror, they're going to get reflected in towards that focal point. Some examples of where we use concave mirrors in society are in flashlights, telescopes, cosmetic mirrors, headlights, solar ovens. Basically anywhere where you want to focus the beam or focus the light into a certain spot. So in this flashlight, for example, that I took apart, the light bulb is right at the focal point. So when the light reflects off the mirror surface there of the concave mirror, it'll all go straight out of the flashlight. In cosmetic mirrors, it'll just make things look bigger. In headlights, it projects the light as well. In solar ovens, you put the food that you want to heat at the focal point, and then all the light coming in will hit the food that you've put there and heat it up. Convex mirrors are the opposite of concave. They curve outward like a bubble. And the focal point in the convex mirror is actually behind the mirror. So there's the focal point back there. So when you have light come in and hit the mirror, it bounces off. And it doesn't go through the focal point, but what it does is it looks like it came from the focal point. So the reflected rays look like they passed through the focal point in a convex mirror. They really didn't, but that's the way they look. So I'll throw a couple more examples in here. That one's coming from the focal point, and that one looks like it's coming from the focal point. Convex mirrors can be used as security mirrors, rear view mirrors, and they can help people see around corners. Some examples that I have found, there's convex mirrors on the front of school buses. So the school bus driver can see what's coming up behind them. Here's a convex mirror I found on a very tight corner to help drivers see what's coming. You'll often find convex mirrors on rear view mirrors in cars. So that little one there is a little convex mirror, but the mirror itself is actually slightly convex. It makes things seem slightly farther away. And then, of course, there are convex mirrors in stores as security mirrors, so people can see around corners and what everybody's up to. All right, that's it for this video. Tune into the next video when we look at ray diagrams of curved mirrors.